Hey guys, my name is Fedis Konyama and today we'll try to talk about graphs. So graphs is data structure and it's very simple compared to other data structure that we've learned before. So yeah, it's just an introductory video, so let's keep it short. So introduction, what is a graph? A graph is data structure, contains two components. Okay, so one is the vertex and the other is the edge. So here, let's explain what does it mean. So graph is a data structure. It keeps the information between two vertices. So the information between two vertices is described by a relation from the edge. And in graph theory, there is this thing called, let's say we have the node A and node B. It is related by relation R. So this is exactly what we are seeing here. So let's say this and this, and let's say the relation is possibly relation something is bigger than the other, or so on and so forth. So yeah, so the graph is a representation of this kind of relation, the relation between two vertices, right? So there are some types of graph. This is called a simple graph, an undirected graph, very simple one. This is a simple graph, and the other one has a direction. So for instance, this kind of direction, for instance, let's say again our relation is one is bigger than the other, then maybe we have this kind of direction indicating that one is bigger than the other. All right, or what kind of other relation, for instance, whether one is the friend of the other. For instance, this node is a friend of one, or this node is a friend of two or three. Okay, another thing in the terms of graph is called degree. What is a degree? A degree is how many vertices connected to that particular node. So for instance, this node here has a degree of 1. There's also 1. This one is 2. This one has 4. This one has 3. And this one has 1. So that's another term. Maybe some other term such as inward and outward direction also matter, like in degree or out degree. Well, that kind of stuff. So as you've guessed, it's used in the directed graph to measure how many edges is directed to that particular graph, or how many edges goes outwards. So yeah. Okay, let's clear this a little bit. Another kind of graph is called the weighted graph. In here, in the simple graph, we only have the relation described by R, but we do not have the weight of the relation. So, for instance, a scenario might be the cost between moving cities. So, if I want to move from one city to another city, how many resources do I need to spend? So, in the edge, there will be values, for instance, like this. And this is a very a very famous one, where you need to find the efficiency, like which one is most efficient to like travel through cities. Yeah, maybe I'll make another video regarding that. Like there are a lot of methods, such as the cycle breaking method. So yeah, the cycle breaking method will find the most efficient path to travel to each vertices with the least amount of resources. So we have the weighted graph, and the method of insertion is very simple. You just need to in the implementation, you just need to like input a vertex and expect they will expect like you it doesn't matter if the content is the same, possibly, and you just need to like say you're expecting that 4 has a relation to 6. Therefore, in the parameter, you might want to input the edge, maybe the weight of the edge, if you have a weighted graph. Weighted graph. and the vertices it is connected to for 6 here and like 3 here. So yeah, depending on the parameter, right? So yeah, it's a very simple data structure. It shows the relation between two vertices or more, and yeah, it can be you see this a lot compared to like tree and stuff like that. So okay, that's an introduction video. It's very simple. So I believe you guys can do it, and see you in the next video. Peace.